Vice.
Good morning, everyone.
Good morning.
Thank you, teacher. Good morning, teacher.
Morning.
Okay, let's humble ourselves and we pray. Our loving Father, one, thank you for today morning. One, thank you for everything. Thank you for enabling us to wake up today. And please enable us to understand the lesson, Father. Please take care of us. Please bless our teacher. Let us understand today's math lesson just like how we've always been doing. Jehovah, I want to thank you for all our parents. Thank you for the provision you've given to the people to help us. And loving Father, please cater for us. Some of those who want to join, please enable them to also rejoin. Father, thank you for being with us. And please let your blessing hand be with us throughout this whole lesson. One, thank you for everything. And please bless us throughout the lesson. In Jesus' name I prayed and believed.
Amen. Okay, thank you so much for the word of
Amen.
prayer. Nice. Okay, yesterday we started on probability space and we looked at how we can generate the probability space. And yesterday I left with an exercise, and it is the first thing I want us to look at. And then I'll ask you to mark yourself depending on what you did in your book. So our first item was that we had a die and we had a coin. So when we talk about a die here we are referring to one, and then a coin, it is one coin. When we use the dice, those are two. So they are asking us to obtain the sample space by using a table. We say that when we are using a table, we know very well that a dice has 6 faces, whereas a coin has 2 faces. It has the head and then the tail. So I expect that our sample space, this side, I can say that this is where I'm going to have my die. So I'll have a 1. It can either show 1, it can show a 2, it can show a 3, it can show a 5, it can show a 5, and then it can show a 6. But we know that if a coin has 2 possible sides, it can have a head and it can have a tail. So that is the sample space when it comes to a tail. So when we combine them and we are tossing together, we can either have 1 and a head, we can have 1 and a tail, we can have 2 and a head, 3 and a head, 4 and a head, 5 and a head, 6 and a head. Then here we shall have 2 and a tail, 3 and a tail, 4 and a tail, 5 and a tail, then 6 and the tail. So whenever they ask you to obtain the sample space, I'll expect you that you present your answer. You say the sample space, the sample space, uh, the sample space for the die and a coin, for the die and coin tossed together is, then you say here, you can say S is equal to, we always represent it like this. Then here you put your different possible outcomes that I can have 1 and H, I can have 1 and T, I can have 2 and H, I can have 2 and T, I can have, here I have 3 and H, then I can have 3 and T, I can have 4 and H, then I can have 4 and T, then I can have 5 and H, then I can have 5 and T, I can have 6 and H, then I can have 6 and T. And this is going to be our sample space. So this is how you represent your sample space. So that was for your Roman A. Then Roman B, they asked that let it be the event that a head and a 1 show up. That means that when you look at your outcomes that we have obtained, you check out where you are able to say head and where you are able to see a one. So the only one I'm seeing, it is this one where I have a head and then the tail. So I'll come here and I say the invent, which I can call E, will give us our sample space as 1 and H. So that is how, so that is the subset, because we say that an invent is a subset of a sample space. And then they said calculate probability of the invent. So I will come here and I say, now I'm going to have my probability of the invent is equal to the number within the invent divided by the number within the sample space. So the number within the invent, we are going to calculate how many outcomes do we have within our invent. And you can actually see that we have only one outcome. Then when you count how many numbers we have within the sample space, the possible outcomes, you are noticing that we have 12 possible outcomes. So here we shall say that our invent is 1 out of 12. Now take note is that when you have 1 out of 12, like I told you, your answer can either be in fraction, it can be percentage, or it can be a decimal. But here, when you look here and you try to put it into decimal, you are noticing that you'll have 0.083333 and so on. So here, when you put it in decimal, it means that you are not going to be accurate unless the question has asked you to put it in the decimal place. So whenever they ask you to put it in decimal place, always make sure you write to at least 4 decimal places. So if the question had asked us to write it in decimal places, then I would have written 0.0833 to at least 4 decimal places. In case it is percentage, then you multiply your answer by 100. So here, I expect you write to at least 2 decimal places for percentage. So you write 8.33%. Or those who want, you can write it as 8 and a third percent. Members, let me know through the chat whether we're on the same page and how many people had it right. How many have that number correct? Okay. Okay, it seems many people were there. Okay. Okay, some people had the number correct. Okay, we can go to the second number we had. So the second number, but when you are drawing your table here, I want to emphasize, you draw a good one, eh? Just because for me, I'm using a free hand, but for you, use a ruler. And also, I want you always to define what you're using. You can say here that let H represent the heads. Let then T represent the tails. So don't use letters without defining what they represent. Now, our second one, the second number, I think this was the second, oh, wait. Okay, the second one, we had 2 coins are tossed together. We say that when we have a coin, still we shall start by saying, let H represent our heads and let T represent our tails. So we say that when we have 2 coins, I'll have this is my table. For 1 coin, this is the first coin. It can have a head, but also it can show me a tail. Then when I have the second coin here, this is my second coin. It can either show me a head or it can show me a tail. So what does it mean? It means that when I toss them simultaneously, I can have a head and a head. Or I can have a head and a tail. Or I can have a tail and a head. Or I can have a tail and a tail. What does it mean? It means that my sample space, I will say my sample space S, will contain these values. It will contain a head and a head. It will contain a head and a tail. It will contain a tail and a head. And it will also contain a tail and a tail. That is my sample space. Now, after obtaining your sample space, they're telling you that your invent A has at least 1 head showing up. By show of hands, who can list for us that subset we are going to, that invent? Which values shall we have within the invent? You can raise up the hand and you tell us what you think. Okay? Yes, Patricia.
I think it's
Good morning, sir.
Good morning.
Okay, I think it's HH, number of
H,
events,
H, mm-hmm,
and HT.
and H, HT. Okay.
Yes.
Okay, thank you. That's what Patricia thinks. What
And
about,
wait,
okay,
there is also TH.
and also TH. Okay, very good. Thank you. Can you first break for us what you understand by the word at least? Paul, don't
Okay.
mute. Mm.
At least I get it like, okay, at least like one, it should be more than one. At least
Oh,
one. If I say at
okay.
least one, then it should be more than one.
Okay. Then, Paul, what do you have to say about it?
I think that the event will be HT and or
Mm,
TH
mm.
because it's saying at least one. So it means, oh, and also HH, then TH because the least number of H is one. So it means it can go above one or it can be one itself.
Okay, thank you. You are correct. Yes, so please, the moment you see this word, at least one, it means greater than or equal to one. It means that the smallest number is a 1, but anything above is also considered. So meaning that when they say at least one head, here we can have greater than or equal to 1 means you can have a 1, you can have a 2, you can have 3, and so on. So it means you can have one head, you can have 2 heads, or 3 heads, or more. So that means we pick all where the head is showing. So here, the head is showing, the head is showing, and the head is showing. Another word they can use on this particular one, they can use the word utmost. So when you see the word utmost, utmost means less than or equal to. So when they say utmost may be 2, then at most 2 heads, it means here less than or equal to 2. So meaning that you can have either 2, you can have 1, or you can have 0. Anything as long as it is less than or equal to 2. So you have to be very careful once you meet such words. So here we shall say that our number within the event, we shall have 3, because you cannot that this is 1, 2, and 3. And therefore, the probability for the event, we shall set the number of elements within the event out of the number within the sample space. So you shall have 3 out of 4. Now, when you reach here, here you still have that liberty. So someone can say, I want to write it in percentage. So someone of percentage, you say 3 out of 4, then times what? 100. And when you say 3 divided by 4 times 100, you'll end up with your 75%. Another person can as well write the answer as a decimal. So you know that 3 out of 4 will give you 0.75. So when it is a terminating one, that one is okay. But when you find that it has very, very many other decimals coming, then that one is really not very, very fine. Members, are we on the same page? Yeah. Yes. Okay. Then we had another one whereby we had a die is rolled, and then we had a spinner with 4 equal labeled 1, 2, 3. So when you look at my screen, I've tried to show you that this was our die, and then this is our spinner. And they are tossed, or they are like running them at the same time. So mean that when you are drawing your table, you can have your table drawn like this, whereby you can say, this way I'm going to have my spinner, which has digits 1, it has a 2, it has a 3, and it has 4. Then I'm going to say that this way I'm going to have my die, which has sides 1, it has side 2, it has a 3, it has a 4, it has a 5, and it has a 6. So this is our simple table that we have. Then after that, you're going to start saying, now this is 1, 1, 1, 2, 1, 3, 1, 4. 2, 1, 2, 2, 2, 3, 2, 4. Then you'll say, this is what? 3, 1, 3, 2, 3, 3, 3, 4. Then you go 4, 1, 4, 2, 4, 3, 4, 4. So you can complete the rest. I can end here. Now, when they ask us to write the sample space, you write here and say my sample space, which I can abbreviate it as S, will equal to, then you open. Then you write all of them, 1 and 1. You write 1 and 2. You write 1 and 3, 1 and 4. Then you write up to when you reach the last one, which will be 6, 6, 4. Then after, you cross. So that's how you represent your sample space. You don't only stop here at the table, but you go on and list your possible outcomes. Then they told us that G is our event, that the sum of the die roll and the spinner result is 5. Now, when you look at the event, they want the sum. So sum meaning that you add. So I expect that now, what are you supposed to do? You look at the outcomes. The die was giving us a 1 and a spinner 1. So when you add, here you get 2. Here you get 3. Here you get 4. Here you get 5. So you add the numbers that show up. 1 plus 4 is 5. Here you 2 plus 1 will give us a 3. 2 plus 2 will give us a 4. This one will give us a 5. This one will give us a 6. It will give us a 4. It will give us a 5. It will give us a 6. This one will give us a what? A 7. So you add those numbers. So please, at times they can tell you sum. Sometimes they can tell you the difference of the numbers. Sometimes they can tell you the multiplication when you multiply them. Sometimes they can even tell you when you divide. So you need to check out, what does the invent say? Does it say summing? Does it say dividing? Does it say multiplying? And at times it is even a good practice that in case the question, let me say, they told you, here they can say, write down the sample space that for the sum when a die and a roll are spun together. So if they want a sample space for the sum, it means that you can first draw your rough table having all the numbers shown, and then afterwards you add them, then you do have that sample space where the numbers are added after. But in case you can do it very well, sharp, it is also okay, whereby you can say 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 4 is 4, like that. So that one can be okay. So, but always you are going to be noticing some kind of pattern. Take an example for this one. You are going to notice that you have some kind of pattern like this. And surely when you look at that sample space, you can say that when when you add them, the result will be equaling to 5. So here, that means that our invent, that whereby the sum is equal to, is giving us that, it means that we shall have pairs such as 1, 4. We shall have pairs such as 2, 3. We shall have pair such as 3, 2. And we shall have a pair 4, 1. So when you add all these ones, 1 plus, you'll be getting our sum as 5. So they wanted us to just identify what G is. But in case they had asked us to go on and find the probability of G, then we shall have counted 1, 2, 3, 4, that there are 4. And how many possible outcomes do we have? That this is 4 by 6, which gives us 24. So in case they asked you to get the probability of G, that's how you can do it. But always here you can go on and reduce and write this as 1 out of 6. Members, let me know through the chat. Are we there? Are we there? Are we? Okay, I think we are good. Any question before we leave this number? Anyone who may have any question? Okay. Okay, I think we are good. Mugisa?
Okay, thanks, sir. Good morning.
Good morning.
Yeah, I have came somewhere late, but I'm requesting for you to display the screen of the first number. I take a screenshot of it, then we continue.
Okay, I'm going to display it at the end. I'm going to display. I'm going to go back in a slow motion. Okay.
Okay.
Okay. Then I have another one, number 4. Number 4 told us that we have 3 coins that are tossed together. What does it mean? Like you have, this is your first coin, this is the second coin, and this is the third coin. Imagine you have those coins, you have placed them in a cup. Now, when you place them in a cup, here, when you are dealing with these ones, you can first toss your 2 coins and say, this is my first coin, which will give me a head and a tail. This is my second coin, which will give me a head and a tail. So when you look at, this is 1 coin, and this is the second coin. So what sample space will you get? You'll get a head and a head, you'll get a head and a tail, you'll get a tail and a head, and then you'll get a tail and a tail. Now, that means that when you toss 2 coins, the possible outcomes will be head and head, it will be head, tail, it will be tail, head, and it will be tail, tail. But now you wanted 3. So meaning that since these ones are already 2, I'm going to add on one more coin. So I'm going to come and I draw my sample space. I say the 2 coins will give me head, 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 tail, tail, head, and tail, tail. So in case I add on a third one will give me a head and it will give me a tail. So then I can combine and say, this will give me head, head. This will give me head, head, tail. This one here will give me a head, tail, and tail, head. This one will give me a head, tail, and tail. Then I'll have tail, head, head. I'll have tail, head, head, tail. I have tail, tail, head. And then I have tail, 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 head. Now, this is going to be your sample space. So you list it very well. You say that now my sample space will have a head, head, and a head, 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 and a tail, head, tail, head, up to when you reach the last one and then you cross. So that is how I expect you to state your sample space. Then for part B, they told us H is the event that all 3 coins show heads. Now for our event, all the heads show heads. It means you have head, head, and a head. So that is the meaning. So you stop there. In case they ask you for probability, then you say that it is going to be 1 out of the 6. Hope members, I think members were on the same page. Yes. Now, members, please take note. HT and TH are not the same things. It means that when I say HT, let me say this is the first coin, this is the second coin. So when I say HT, it means that on the first coin, I had a head, the second coin showed me a tail. In case I say TH, it means that the first coin showed me a tail when I tossed, and the second coin showed me a head. So these are different tosses. These are different tosses. The first toss, you got a head showed up and a tail. The second toss, a tail showed up and then a head showed up. So those are 2 different, different experiments that you have carried out and you are getting different results because we say these are random things. Okay, let me hope I've answered. Okay. 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 The probability remains the same, eh? The probability remains the same. So there is no harm you reducing the what? The probability. Yeah. So when I have 1 out of 2 and another person is having 2 out of 4, these are the same things, but this one is in a reduced format. So when you have your probabilities, always feel free to reduce them. Then we had this number. They told us suggest a suitable sample space and identify the subset corresponding to the event. You had a coin which can show head or tail is tossed 3 times. It is in the event that the coin shows twice. So we have just done a coin that is tossed 3 times, and for head showing twice, I expect that now members can just put in the chat the answer for that. Members, put for me the answer, what you expect to be your invent. Shows heads twice. Put the answer in the chat and I see now. Let me take you back to the table where we had about it. So let me check whether members are following, whether they can put I'm just okay. Paul is saying head, head, tail, tail, head, head. Okay, okay. But but I'm not saying there is something still missing. Paul and Patricia, they said it shows twice. I think it was twice. Yeah. Okay. So I expect when they say a head shows heads twice. So you come here in your sample space, look for where the heads are, but at least when they are two. So one of it is here, you have another one here, you have another one here. So that is going to be your sample space. So kindly check out if that's what you did, you have those three, then it means you are correct. So those are the three I was expecting for that particular number. Okay, that one we have finished. Then this one, they told that a game of football is played. It is the event that the match is drawn. Now, those who are not into sports, I want you to remember, Daniela Joy, you have added one more. You have added one more. Okay, you have just repeated HHT. Okay. Yeah. So those who are not into football or who are not involved in games, you need to have that some knowledge about different games. Yeah. So when you go in for a football match, there are how many possible outcomes do we have? Someone can raise up the hand and you tell us. When you go in for a match, what do you expect as a team? Yes, Gift.
The possible outcomes are three. One is the win, the
You
lose, and
can
then the
win, you can lose, or you can
draw.
draw. Okay, yes. Those are the possible outcomes. Whenever you go in for a match, that's what you can expect, either to lose, to win, or draw. What about there is a game okay, let me first ask you such that I confirm. What about, is it lawn tennis? I think it's called lawn tennis. Lawn tennis. What about that game? What are the possible outcomes? Those who play that game. Okay, I think we don't have people who play it. Uh, so you need at least to have some information. I don't know whether in what? Other games like basketball, games like volleyball. Yes, there is a game I know whereby for it, you either win or lose. There's nothing like a draw. Yeah, but I think you can. Is it chess? Maybe. Yeah, so you'll find out about those games. So here, I expect that your event will have just a draw. Then the last one, the last question, they told us that we had a couple that had two children. It is the event that both are girls. Now here still, you need to know that you can have, when we have a couple and they have two children, that means that there are possible outcomes. But here, I think you need to share with me, what do you think are the possible outcomes? What do you think are the possible outcomes? What do you think are the possible outcomes for such a family? Since people don't have, okay. Yes, Samara.
Teacher, good morning.
Good morning.
Teacher, may I say the possible outcomes can either be, because the question is a couple has two children, is the event that they are both girls. Possible outcomes, it can be a girl and a girl, the first outcome. Then the second outcome can be a boy and a girl. Third outcome can be a boy and a boy.
Okay.
Yeah, I think those are the possible outcomes.
Okay, thank you. Okay, now here we are going to have it like this, that this is our boy and this is our girl. So this is like the first when the mother gives birth, when the mother maybe gives birth. So this is the first time. Then this is the second time. So we have their chances that at like what Amara is telling us, that it shows that the first time the lady gave birth, she gave to a girl, and the second time she gave it to a girl. This one means that the first time she gave birth to a boy and then after a girl. This one means that she gave birth to a boy and this one is to a boy the second time. But there is something missing on it. Yes, Chisache. So also there's a chance that she can have first given birth to a girl and then after she had a boy. I don't know whether Amara you have picked it. So here in the table, we can have a boy and a boy. We can have a boy and a girl. We can have a girl and a boy, or we can have a girl and a girl. So, but remember that this is the first time, and this is the second time when she's giving birth. Yes, but here our assumption, because some of these numbers you need to be very careful. Now here the assumption I'm taking, that this lady did not give birth to twins. That is one of the assumptions. So in case they ask you for assumption, because some of you can say that the lady might have given birth to twins, and she gave birth to girls. So here our assumption is that she's giving to a normal birth of one child per pregnancy. So that is the assumption. So the event that both are girls is going to be 1. And then in case they ask for probability, then it will be a quarter. Okay, members, hope we are together. Are we together? I want us now to start today's work. Are we together on that? Let me know through the chat whether now we're on the same page. Okay. Okay. I'm going to go back. Those who wanted number 1 is there.